Welcome to the Deep Dive. We're here to cut through the noise, giving you the crucial AI and science insights you need, fast. This is episode 320.
Straight to the point. Today, we're unpacking, well, a massive shift in weather prediction, plus Google's push for AI that actually keeps learning, and then a roundup of some truly mind-bending science breakthroughs. Think forensics, deep space. It's quite a mix.
Okay, let's jump right in with AI versus Mother Nature. We need to talk about Google DeepMind's Weather Lab.
Right, this is a big one. Their AI model, the Weather Lab, it actually outperformed traditional weather forecasting this past hurricane season, 2025.
Outperform the established methods for predicting hurricane tracks and intensity.
That's right. And the key difference here is how it works. Traditional models, they're all complex physics simulations, decades of refinement there.
Massive computing power needed, running all those fluid dynamics equations.
Exactly. DeepMind's model, it's different, fundamentally data-driven. It learns atmospheric dynamics from observing just tons of data, historical and real-time.
So it sort of bypasses the need for writing out all the physics rules explicitly.
In a way, yes. For the initial modeling, it learns the patterns.
Yeah.
And what's really impressive, maybe the key benefit for you listening, is the speed. It learns from mistakes, corrects forecasts quickly, much faster than running those massive traditional simulations again.
And that speed is critical when you're talking about severe weather, like hurricanes bearing down.
Absolutely. This isn't just about slightly better forecasts. It reflects a bigger trend using AI for environmental prediction, better accuracy, faster warnings. That ultimately saves lives. Simple as that.
A really serious impact.
Yeah.
Okay, so from predicting nature's complexity, let's pivot to, well, the complexity of building truly smart AI, Google's HOPE model.
Right. HOPE. This one's trying to crack a really fundamental problem with today's large language models, LLMs. It's called catastrophic forgetting.
Catastrophic forgetting. For anyone not deep in LLM research, what does that practically mean?
Okay, think of it like this. You train a huge model on, let's say, book A. It knows book A really well, then you try to teach it book B. What happens often is, poof, it completely forgets book A, or its knowledge gets badly garbled.
So it can't really learn new things without wrecking its old knowledge. That sounds like a massive roadblock for, ongoing learning.
Exactly, a huge barrier. You can't build a truly dynamic learning system that way.
So how does Hopi get around this? I saw something about nested learning. Sounds technical.
It sounds a bit like jargon, yeah, but the idea is actually quite elegant. Instead of one giant brain, nested learning treats the model like a system, interconnected levels of learning problems, almost like specialist modules, some for deep memory, others for quick updates.
So it's structuring the knowledge, building components with more computational depth so new info doesn't just overwrite everything.
That's the idea. And the early results look good. Hopi's showing higher accuracy, lower perplexity. Basically, it's less confused compared to current LLMs on language tasks.
Okay, wait. If it's got this complex nested structure, this depth, doesn't that make it way slower or more expensive to run day to day? Is there a trade-off?
That's the crucial question, always. The initial training is complex, but the goal of this architecture is actually better efficiency for continual learning, because it doesn't have to constantly retrain the entire massive model to add new stuff without forgetting. The incremental updates should become more streamlined over time. That's the hope, anyway.
Okay, that makes sense. So solving this forgetting issue,
yeah,
it's a really big step. It feels like it pushes towards that idea of artificial general intelligence, AGI, machines that can learn and adapt over time like we do.
It's definitely a key piece of that puzzle. It shows Google's still aiming for those fundamental breakthroughs. Right, now let's switch gears again. Let's do a quick run through some other amazing science news hitting today, from crime labs to outer space.
Starting with what sounds like a holy grail for forensics.
Yeah.
Irish scientists figuring out how to get fingerprints off fired bullet casings. I thought that was basically impossible.
For decades, yeah. Everyone thought the heat and pressure of firing just destroyed any print completely, obliterated it.
So what did they figure out? How do you get around that kind of damage?
They developed this electrochemical method, uses a mild voltage, some non-toxic polymers, very controlled setup, and it makes the fingerprint ridges visible again, like within seconds. And it works even on casings that are pretty old, up to 16 months, they said.
Wow, the implications. Linking ammo directly to who loaded it, not just the gun it was fired from. That could change cold case investigations dramatically.
Potentially, yeah. Huge. Okay, now let's zoom out, way out, to deep space. Caltech astronomers spotted, well, possibly the most powerful cosmic event ever recorded.
More powerful than anything we've seen before. What was it?
A supermassive black hole caught in the act of violently eating a star. And not just any star, one about 30 times bigger than our sun.
30 times bigger, getting torn apart by a black hole. I can't even picture the energy release.
They measured the flare. It had the power of 10 trillion suns.
10 trillion. That's staggering. And it wasn't just a quick flash.
No, that's the other thing. This thing happened 10 billion light years away, and the event, the energy output, has been going on for over 7 years now.
7 years. It just shows how much extreme, almost unimaginable stuff is happening out there that we're just starting to glimpse.
Exactly. Okay, back down to Earth. A really clever bit of clean energy tech from China, a floating generator called WDEG.
Floating. And it does what?
It floats on lakes, reservoirs, and it converts the energy of falling raindrops directly into electricity.
Rainfall into power. How efficient can that be? And how does it work floating?
Well, the clever part is the design. It actually uses the water it's floating on as part of the system, as both the support structure and an electrode.
Using the lake water itself.
Yeah.
That sounds like it would make it much lighter and cheaper.
Exactly. Cuts the weight by about 80%, they estimate, and the cost by maybe half compared to conventional floating systems. So you could see this being great for off-grid power or maybe boosting existing solar or wind farms that are near water.
Very neat. Okay, one more science breakthrough. This one tackles disease vectors, a genetically modified fungus that acts as a mosquito death trap.
Yeah, scientists tweaked a fungus called Medarhizium. They engineered it to release a compound, longopholine.
Longopholine, what does that do?
It smells sweet, apparently irresistible to mosquitoes. It basically lures them in.
So it's like a siren song for mosquitoes. They fly towards the fungus.
Yeah.
Then what?
Then they get coated in its spores. And these spores are lethal to them. In the lab tests, it lured in and killed 90 to 100% of the mosquitoes.
90 to 100% kill rate. That sounds incredibly effective, especially thinking about diseases like malaria, dengue, where mosquitoes develop resistance to sprays.
Right. This could be a powerful tool because it's biological. Harder for them to develop resistance to a fungus they're attracted to. Offers real hope for affected communities.
Okay, that's a fantastic roundup of the science side. Before we wrap this deep dive, let's quickly spotlight some AI tools that are trending right now. Give you some practical things to maybe check out.
Yeah, looking at the tools, you definitely see themes. Making complex development easier seems big right now.
Like MeDo by Baidu. That's for building full-stack apps with AI help, affordably. Shows that push for accessible AI dev tools, including from major players in China.
And then there's the rise of specialized AI assistants. We're seeing things like Jinna.ai. It focuses specifically on business admin, finance tasks, day-to-day operations, sort of like an AI chief of staff.
That chief of staff idea pops up again with Ancher. It's pitched as managing your information flow, helping you stay focused in all the digital noise. Personalized focus management.
In the creative tech space, there's Dazl. They're calling it the next era of vibe coding, which sounds a bit out there, but it points to more visual, intuitive editing for everything digital, less pure code, more visual manipulation.
And with AI getting integrated everywhere, security is obviously top of mind. Multifactor is interesting, a password manager built for sharing secrets securely between humans and AI systems. That's a very modern problem.
Definitely. On the bigger enterprise scale, you see tools like Golf. That's a firewall specifically designed for managed cloud providers, MCPs, hardening that infrastructure. And if you need web data, maybe for training models or monitoring, Firecrawl v2.5 is getting attention as a top web data API.
Finally, for content creators, there's BlogBowl. It uses AI to generate keyword-focused articles and can even auto-post them to your blog. Automation hitting content generation hard.
So we've covered a lot today. From AI getting a handle on hurricanes, to pushing the boundaries of continuous learning with HB, all the way to cracking forensic puzzles that stump people for decades using just a bit of electricity. It's quite the range. And maybe a final thought for you to chew on this week. We're seeing AI make rapid progress in these really complex, unpredictable systems, weather, learning itself. How might that success change how we tackle research in other complex fields? Fields still dominated by traditional models, like, say, climate modeling or maybe drug discovery. What other boundaries are about to fall?
That's definitely something to think about. Thanks for joining us on this deep dive. If you found this useful, please do follow the deep dive. And share this with anyone else who wants to get these